Welcome to the Explainer. Okay, today we're setting the stage for exploring a piece of technology that is literally poised to completely transform how we interact with information. We're diving into this incredibly fascinating monograph from a company called DBbun LLC, and honestly, it outlines a future that feels a bit like science fiction, but it's happening right now. We are talking about a massive shift moving beyond just reading a document to actually interacting with it, going from static text to running live code. So, I want you to start by asking yourself this one provocative question. What if the documents you read could actually run? Just imagine reading a dense, super complex document, and instead of just kind of passively absorbing the text, you could actually launch it. You could play around with the variables, test the core assumptions, and watch the outcomes happen in real time. Well, that is the core thesis of DBbun, taking static, inert text and turning it into living, interactive simulations.
Okay, let's dive into this. Section 1. The static knowledge problem trapped in the page. To really understand the solution here, we first have to recognize a universal frustration with the way we currently store knowledge. Right now, humanity's most important information is fundamentally trapped. Just think about scientific papers, patents, complex mission specifications, challenge descriptions, technical diagrams. These are absolutely vital formats, right? But they're essentially inert. They just sit there on the page. If a scientist wants to test a method from a paper, or say an engineer wants to explore a patent's design space, they have to do the painfully slow, expensive, and frankly inconsistent human work of translating all that text into a usable, computable model. The human reader basically has to build the simulator from scratch every single time, and that creates a massive bottleneck for innovation.
Section 2. Meet the executable companion, turning content into simulators.
So what if we didn't have to do all that manual translation? This brings us to DBbun's paradigm-shifting approach. They realize that a lot of these artifacts already contain hidden computational systems. Entities, variables, mechanisms, state changes. They just need to be unlocked. And that unlocking process creates what they call the executable companion. It's a runnable software environment generated directly from a static artifact. Now, to be clear, it's not just a text summary. It's a complete bundle containing actual code, structured data, figures, parameters, and scenario logic. It moves way, way beyond just asking an AI to summarize a PDF. It's about creating an interactive, operational package that a human can rigorously inspect and test.
So the crucial point is captured beautifully by this core concept from their monograph. They describe themselves as a compiler for knowledge artifacts. Really think about that for a second. Just like a standard software compiler takes human-readable code and turns it into something a machine can run, DBbun acts as a compiler that brings static knowledge to life, giving you a runnable companion. It just seamlessly bridges that massive gap between static content and interactive understanding.
Section 3. How the transformation works. The debug pipeline.
You're probably wondering how this actually happens under the hood. Well, there are 4 distinct steps in the DBbun pipeline. First up is input ingestion, taking in the raw documents, images, maps, or technical files. Second is structural interpretation, where the AI systematically hunts down and identifies the variables, constraints, and logic hidden deep in the text. Third is executable generation, which produces actual runnable Python code and structured data. And finally, simulation and output, where it runs the scenarios and generates figures. What's absolutely vital to note here is that this is human in the loop. It generates the documentation and packages the whole shebang up so a human can review, iterate, and refine the model with total precision.
And this structured workflow is exactly why this is so much more powerful than just typing a prompt into a standard AI chatbot. Look, an ordinary LLM answer gives you this transient, prose-only conversation that's incredibly hard to reproduce later on. It's kind of just a one-off prompt. But a DBbun companion package, it's a shareable, productized bundle. You get stored files, rerunnable scripts, code, figures, and crucially, traceable provenance. It completely exposes the exact assumptions used in the model, so you can actually verify how the simulation was built. This is a rigorous engineering workflow, not just a casual chat.
Let's move to Section 4 and see how this builds into something amazing. Simulations in the real world, wild proof points.
We're going to significantly ramp up the pacing here because DBbun's real-world proof points are genuinely mind-bending.
The sheer domain versatility is off the charts. They generated synthetic heavy-lift aircraft datasets for the incredibly complex DARPA Lift Challenge. They explored small-n human research methodology for NASA's Artemis II spaceflight. They literally won a $10,000 Phase 1 cash prize from the NIH for modeling biomedical toxicity, meaning they were working with highly complex genetic and chemical structures. And they even built measurement-aware clinical AI evaluations using HL7 healthcare standards. I mean, jumping from aerospace specs to winning biomedical prizes without missing a single beat is just astonishing.
And this brilliantly illustrates the blazing real-time speed of their platform. On May 30th, 2026, a meteor was reported exploding off the coast of Massachusetts at exactly 2:11 p.m. By that exact same afternoon, DBbun ingested the breaking news articles. Now, we're not talking about archival, peer-reviewed papers here, but live, rapidly developing news. And they published a fully functional Python simulator and synthetic datasets all on the very same day.
To put the sheer scale of that output into perspective, within literal hours of the public event, they transformed breaking news into an executable scenario bundle that modeled 5 completely different entry angles for the meteor. It generated burst altitudes, peak luminosity distributions, synthetic witness reports, and 8 publication quality figures. It is rapid simulation communication in action, proving for sure that complex modeling can actually happen at the speed of the modern news cycle.
And the commercial appeal is just as strong as the scientific one. They tested the platform on materials from an AI startup called Rolodex to help them explain their deeply complex system. The co-founder's reaction was beyond ecstatic, calling it incredibly helpful and an incredible tool. DBbun was able to generate a bundle with documentation, runnable code, and analysis figures that let the startup actually demonstrate their technical value to stakeholders instantly.
Which brings us to Section 5, the meta-stress test and market. DBbun analyzes itself.
Okay, so this is a really fun, almost meta-plot twist for our explainer. DBbun actually ingested its very own business monograph to stress test itself. Yeah, they've fed their own foundational document into their pipeline to evaluate their own market viability. The system ran 4,000 Monte Carlo simulations. That's 500 runs across 8 different domain scenarios just to see exactly where their own company was most likely to succeed, all based on the facts and assumptions laid out in their own text.
Now, what's really interesting about this internal audit is how completely impartially the AI scored its own potential. It found that the absolute strongest near-term market fit was actually in startup and marketing explanations, scoring a 0.76. Scholarly publishing was right behind it at a solid 0.72, but it actually flagged IP and legal diligence as a much weaker initial path, scoring it at just 0.48. The platform literally told its founders where to focus their business strategy right out of the gate. How cool is that?
Based on that massive discovery, they mapped out a huge commercial scope. For scholarly publishers stuck dealing with inert PDFs, DBbun offers companion demos to vastly improve reproducibility. For aerospace and defense folks dealing with hard-to-explore mission constraints, they offer design space scenario bundles. For startups and marketers who are struggling to explain complex systems, they provide comprehensive demo bundles and explainer videos. And for healthcare AI, standards-aware measurement simulators. They map totally diverse target customers directly to highly specific, tangible, runnable pilot artifacts that solve real, immediate pain points.
Let's slow the pacing down a bit for Section 6, the future of knowledge beyond the PDF.
We really need to reflect on the broader societal and scientific implications here, because we are talking about fundamentally moving away from static text forever. This isn't just a neat little software trick. It's a massive evolution in how humanity records and tests its knowledge. And this shift is being recognized at the absolute highest levels. Yuri Cartoon, the founder of DBbun, published a letter in the communications of the ACM arguing that scientific papers must become executable interfaces. And Vinton G. Cerf, literally one of the fathers of the internet, responded positively. He resonated deeply with the proposition, noting that if AI helps improve the scientific method, everyone is well served. I mean, that is massive, undeniable credibility for DBbun's underlying philosophy about the evolving role of how we share information. And that leaves us with this final, truly thrilling thought. We are entering a brand new era where you don't just read an idea, you run it. So I leave you with this question. When every single document becomes a simulator, what will you build first? Thanks for joining me on this explainer. I hope this completely changed how you look at the text on your screen.